Hi everyone, my name is Isabella and I'm one of the founders and the CEO at focalx. And what we do is that we help companies in the automotive and logistics industry with their vehicle handovers. And to do that, we use computer vision technology. And that is one of the things that I'm going to talk to you about today. But I'm also going to talk a bit about how we're overcoming the data challenge, because that's been one of the main issues that we've been facing building computer vision models. But first of all, I'm going to tell you a bit about what we do at focalx, so you have some idea and some framework to put it all into. You might not know this, but when I am finished with this sentence, at least $10,000 will have been lost because companies are not detecting damages on cars when handing them over. And every year, more than 9.2 billion cars are handed over. Today, it's either manual or the inspections are non-existent. You've probably seen this one over here while renting a car or something like that in south of Europe. It's a pain. But what is a bigger pain is when inspections are not happening. And as a result, companies lose a lot of money because of inefficiencies and non-detected damage on cars. And that's essentially what we're solving. So with focalx, companies can cut down cost and time on their inspection processes by making them more efficient, but they can also detect more damage on cars. And that's where we're really saving them a lot of money because they're able to report it to the insurance and so on, and they're able to create transparency around the responsibility of the damage. So our product is as simple and sexy as a calculator. Our customers call it the smart camera. So using highly sophisticated computer vision technology, we guide the user around the car to take images, and based on those images, we generate a damage report showcasing all of the flaws on the car, and then we hand it over to the company. Our models are trained with hundreds of millions of data points, and we're continuously keeping up to date by creating even more data using synthetic data methods, amongst others generative AI and other damage transfer techniques. And that is something that I'm going to talk a bit about. But just to give you an idea of how our models are structured and what we do in terms of that. So detecting damage on cars, it sounds like an easy task, but there's actually a lot of things happening here. So we have 3 different layers of models. There's the top level, and these are happening sequentially, or the first things happening. Is there a car in the picture? What position is the car in? What parts do we see on the car? And what minor parts do we see on the car? That's the first things that happen. After that, we run all of our damage models simultaneously. That could be scratches, dents, tears, stone chips, and so on, to figure out what damage is on the car. And then we have another layer on top of that, calculating 1, the severity of that damage, and 2, validating that it is actual damage on the car. Because often a dent could also look like a reflection or the other way around, and dirt could look like a scratch. So to give you a couple of examples of the type of damage that we currently detect on cars, here we see a black car in both of the images. It's a bit difficult to see on the right image. But here, take the first one. You see a black car door where you see a lot of things reflected on it because it's very reflective. And you have a small scratch there pointed out with the yellow arrow. Over here, you also have a black car door. And here it's not that easy to see that it's actually not a white car. But it isn't. That's just reflected. And you can even see like the phone over here taking the image. And these are the kinds of conditions that we often work under while detecting damage on the car. And you can then see we detected the scratch here. Here's another couple of examples, and just to give you some ideas of what these models are able to do currently. So this one here is a good example because what you can see is that we detected a dent, but we didn't detect the line here that could look like a scratch, but it's actually a reflection. Today, we are already being used by companies like Applush and now in Vigo as customers in Denmark, and also across Americas, MENA region, and Baltics. And now we come to what I really want to talk to you about today, which is the major challenge to get there and to actually being deployed and used all of these places around the world, and we are only a 2-year-old company. The biggest challenge to get here has been data, because now you've seen a couple of examples of the things that we need to detect, and it's very varied data. It's different colors of cars, it's different body types, it's a lot of different environments that we work under. So how can we do that? In general, there's a couple of ways of getting the data you need to train models, and models like these need a lot of data to be trained. So there's a couple of ways to do it. One is collecting data in-house. You can do this if you're already a big company and you have some data streams, or you can do it by starting out with a non-AI product to start getting that data that you will need, so you get real-life data. But we actually tried this approach. It wasn't hugely successful because our product without the AI just wasn't as interesting for our customers. Then you can create industry partnerships, and this is a normal way of getting the data as well. But it can be tricky to find the right industry partners that have that type of data. There's also internet databases where you can find data, but if it's very specialized data, it can be difficult. And then there's the fourth, which is scraping the internet, but this is increasingly becoming illegal. MIT made a research paper showing that more than 50% of all AI projects failed because of them not having high-quality training data. But the solution is right here, synthetic data, and Gartner predicts that synthetic data will overtake real-world data in AI models by 2023, which is basically now. And this is their predictions. So it's also by a substantial amount. So we started looking into this. How can we use synthetic data? How can we generate synthetic data to create our models? The way that synthetic data is usually created today is in Omniverse or Unreal Engine, like gamified environments where you can have non-real-life looking data, but it is good enough if you want to detect zebras or something like that and just need the basics of a zebra on a field. Then it's not a problem at all. But if you want to detect damages like we need to detect that are very varied in format, you cannot really use any of the tools out there. So we build our own. And the process overall looks like this. So we either identify or 3D generate damage. We take our data set of hundreds of thousands of cars, and we simply place that damage onto the other cars. Obviously, this is not as simple as it sounds. There's a lot of things going into this, because the angle needs to be right, the type of damage that you place at a certain place needs to fit that part, and there's a lot of complexities in doing this. So we started out doing it manually, and I can actually show you guys a brief video of what that looked like. So you can see it here. This is a way of manually moving one damage to another place. And so there's color differences, there are all sorts of challenges while doing this, although just moving a bit forward, it is possible to get it to look like a real damage and then to copy it all over the car. Like, this is the very basic, very manual way of doing it, and the very first thing that we started doing. Now, obviously, this isn't as efficient. So we started developing generative AI models for doing it. And I can just show you also what that look like at a very small scale. Obviously, we are automating this process and working with it continuously. But we are then training generative AI models on the type of damage that we know are important for our customers to see. And this is a very bad version of it because this is Photoshop's version of it. It doesn't work at all. So that is why we are training our own AI models to do this. So you get an idea. Okay, let's go back to the presentation. Yeah, here you can see another couple of examples. What is interesting here is that you see the same damage here as here in different sizes, in different colors of the car. So this is also something that we're training our models to do because it needs to fit with the color, with the part, with the angle, with the light, with the shadows, with the reflections, and so on and so forth. So it's not a simple process as such. But this is essentially what helps us create the data sets that we need to train our models for our traditional AI models. So here you also see a couple of examples. All of this is synthetic data. Can give you a couple of more. They look like real-life car damage, but they're actually not. The results astonished us. So before we started this process, we were struggling with especially one model that we just couldn't get to work because reflection has such a large impact on that model. For these types of models, an F-score of 0.6 is amazing. Like, you rarely get that with these types of models because it's such small objects and so many variations of it in so many environments. But we managed to increase our F-score from 0.3 to 0.7 when we included our synthetic data. And yeah, we also increased the efficiency of our annotation tool a lot. So why does this matter? It matters because we can now automatically and by ourselves create the type of data that customers want and need for their use case to really make sense, to really get an ROI from our tool. Not a lot of companies do this. Not a lot of companies manage to get the data that they actually need, especially not if it's very specific models that they need. But I am strongly convinced that the companies that will manage to do this and work with synthetic data also will be the ones that win. So, thank you for your time, and if you have any questions, I'd love to answer them.
Good. Let's see if we have any questions in the audience. And will you be the runner again?
Yeah.
Excellent. Cool. Or there might be some online. So might we actually have experienced your software already? You said that it's deployed in Danish companies as well.
So we're always starting with the internal processes. Mm-hmm. So when you see that ShareNow is using it, if you ever see ShareNow personnel running around taking images of the car, they are using our tool.
Okay.
But it's not implemented in their end user app at this point.
Okay.
The same goes for Vigo cars and so on.
Yeah, because I thought maybe I'd tried it when I got a Go More car and I was like out filming.
No, I either, unfortunately.
Not yet. Not yet. It's coming.
Yeah.
Excellent. Let's see if we have more questions from the audience. Maybe you covered it all. I'm super curious though, because it seemed difficult, even for a human eye, to distinguish between the reflection and an actual scratch or dent in the car. Like, what types of algorithms and machine learning do you use for that?
So first of all, we created everything from the bottom. You can find open source models out there on the internet that can easily detect a black thing on a white car. But in reality, these models aren't that useful because they don't take into account all of the different characteristics of it. So we actually built it all from the ground up, and that goes for all of our tech stack. Essentially, we built all of our annotation tool, moderation tools, like build a lot of tech in house. An important point here is also that, because you said it can be difficult to distinguish between dirt and damage or reflection and so on. And what we do here to ensure that our models predict accurately is that we run a lot of models. We don't overtrain each single model, and we also customize models for the customers itself, so that we don't try to grab everything in one model, because then we're overtraining and the models are becoming confused, because you see cases like this where you have like a lot of reflections, for example.
Cool. There's some questions online, it seems.
Thank you very much. We have a question here from our online audience. What do you think of using synthetic business data in terms of scenario simulation and in financial applications? Does that make sense? Synthetic data used in financial applications.
That's not really my field. I must admit. I know mostly of using synthetic data with computer vision models. To me, this is a really good application for it, because it's quite narrow, although you're now also seeing that it can be kind of broad. But with financial data, sounds a bit risky.
I think I'll recommend that the person who asked the question track down a guy called Joran, and he's a speaker at Digital Tech Summit, actually. He's from Synthetic AI Data, so maybe talk to that company. They might know.
Yeah, so there's a lot of synthetic data options out there, and I'm just talking about computer vision and image data in particular, because that's what we really try to figure out how to do and how to find, and we couldn't find anything, so we built it ourselves.
Way to go. Let's see if there's more questions in-house. I see one over here.
Thank you for your presentation. So when you're using synthetic data to train your models, how much synthetic data are you using compared to real data? And how often do you have to retrain your models if your models kind of, because you're using generative AI to train AI, so there has to be some types of issues when it comes to recognizing, dents, scratches, whatever. But how often do you have to kind of go back to the drawing board and start over with your models?
So first of all, we have a really strict QC process on everything that we do. And because we also started using synthetic data this year, we still go through everything. We have a whole annotation team that is also moderating that data coming from the AI and vetting everything before we send it to the AI. So it's not in any way an automated process at this point. And I think that's where we will really face those issues of retraining. But obviously, because we are a startup and because we're 2 years old, we continuously retrain the models anyways. In terms of the amount of normal real-life data and synthetic data, I would say it's 90-10. So we use it to tune and tweak the model. So we have a base of real-life data that we then work on top of with the synthetic data. So it doesn't stand alone, but it has helped us increase the accuracy immensely and focus towards the things that are more important for our customers, because that's also an important distinguishment. Does it make sense?
And do we have more questions in the audience? We have one over here.
I'm just trying to understand how it will work in practice. So if I'm returning a rental car, and then the rental agent, he has to take pictures from every angle and upload it to your software, and then you get immediate feedback, right? Is that how it works?
Yeah.
Yeah.
Yeah, that's pretty much how it works. So we start with the internal processes always. A car rental could be one example. We have a lot of other examples. It could be car logistics as well, when cars are transported from one company to another, and there needs to be transparency around the condition. So with the software, we made it so simple to do that the inspection can be done every time. And the process to take the images, and we have gone for images and not video because people are better at doing pictures than video. But we found out that it's something that anyone can do. And we have really worked on our cloud infrastructure to make sure that the results are immediate. So whenever the inspector is done taking the images, they already start see damages appearing in the report.
All right, thank you.
So you mentioned that you're a 2-year-old startup, and working with startups, I'm always curious about what are your next steps. Are you in need of brain power? Are you recruiting currently? Are you looking for investors? What would be a next step for focalx? How can we be a resource to you?
So, of course, we're always looking for great interns. Being a startup, we are not hiring massively right now, but we are looking to raise a larger funding round next year. So then there might also be some more opportunities of hiring more. But interns always, and if anyone are business angels and stuff like that, we're always interested to talk, of course. But yeah, right now we're just working on pushing our product out to customers, and that's the main focus of the business right now.
Totally makes sense. Thank you. I think we have room for one more question. Are there any online or any I see one over here.
Hi, thank you so much for the talk. So I'm just curious about the bias in the data when you start to use these synthetic data. So basically from what I understood from your talk, so you have few, let's say, damages in some of the real cases, and then you try to take those and of course put it with the right. So some sort of bias is already introduced because of those real kind of data. So how do you tackle these kind of problems to avoid bias?
That's where the very close customer dialogues come into play, because that's really a cornerstone of what we do, that we align with the customer on what is important for them to see, because that way it's easier for us to generate that type of data and train the last 10% with that type of data. What we also do is that we only train generative AI models on real life data that we know is relevant, and we also have this very hefty QC with two layers of that process to make sure that the data is proper and what we need.
Thank you so much.
And let's see, do we have more questions in the audience? At DTS online? No. I think we're complete. Thank you so much for an inspiring talk. I'm gonna switch back to my advertising slide here, because in case somebody has more